This one's pretty easy, right? Because it's just looking for a number times itself that's 24. 24, we've done this one more than once. 24 is not a perfect square, but 4 times 6 would be the factors you want, because 4 is the biggest perfect square that's a factor of 24. And the reason you want that is because that can be simplified to just 2. Right? So as far as simplifying square roots, that's about as easy as it gets. This one's probably easier, but people mess this one up all the time. That's 100 times 2. Not 10 to the 10 times. If you say 10 to the square root of 2, then that's what that means. And that's different. So when you say it, that's what it means. It means 10 to the power of the square root of 2, which is about 1.4. All right. Brandon, you got those two correct?
Yep.
And this one's pretty easy also. It's 3 root 3.
Yeah.
Because that's 9 times 3 is 27, right?
Yeah.
Square root of 9, 3. This one, a little trickier. 4 times 2 times x squared times x. Well, I'm not done yet. I'm not talking about the answer. I'm talking about how you factor it, right? So, are we good? That's 8. And Tristan, we're good that that's x cubed? Okay. Square root of 4 is 2. Square root of x squared is x. What you're left with is 2x. So it's 2x times the square root of 2x. Carlos, any questions so far? So far, so good. Yeah, it's the same. It's the same. So here's what his question was, if you didn't hear it. Mikey, his question was this. He's like, instead of writing it all under one square root, can you write it like this if you wanted?
Which way is better? The way that you understand it.
Which way is better, spaghetti cut up or on a spoon with a fork? However you like. There you go. This one, okay. Done. Don't leave it blank because it's already simplified. That means you skipped it. Right? Yeah. Oh no, this one is 4 being multiplied by that, right? And the square root of a squared is a. So this is 4a square root b. You want to know the most common wrong answer? This is the most common wrong answer. What happened? What?
The 4 is on the outside. It doesn't fit.
But that's what people do. They're like, oh, I got a perfect square.
Yeah.
Yeah, so yeah, like I got a square, there's a 4 perfect square, 4 perfect square, there's a 2. The 2. Right. But that's just 4 as in 1, 2, 3, 4. Okay, next up, Buttercup. I am pretty sure that 98 is 49 times 2.
Yeah.
And the square root of 49 is 7.
Yeah.
And I'm pretty sure that the square root of x squared is x. So I'm just thinking, I'm thinking that's 7, that this is 7x times the square root of 2. I'm thinking this part equals 7x times the square root of 2. So I think it's going to be 21x squared times the square root of 2. Yeah? Anaid, do you want to see that?
Wouldn't it be 24?
Let's just look at this part right here for so far, okay? That's 49 times 2 times x squared. That's 7x times the square root of 2. 7x times, remember there's a 3x in front, right? Right, so that's 21x squared times the square root of 2. Tristan, did you get that one right? Oh, I'm glad you're fixing it. That was that new sarcasm thing I'm working on.
Can I be a co-member of the sarcasm club?
Sure, let's do that. Okay, This one, Parth, what do you think about that? Yeah?
I got 1x.
Oh, you got 1x like that?
Yeah.
That's different.
I got one next to times. Oh, I just got to simplify.
That's 1/3, right? Square root of 9. See, look, there's a property of square roots. Like, this is true. You can separate them. You could, yeah, they're exponents. Square roots can be written like exponents, so you can kind of like group things together differently. But square root of 9 is 3. 3 goes into 3 one time. You're left with 1 over x. Anna, doing good or bad? Good? That's funny. So the ones that you thought you got wrong were right. What about the ones you thought were right? Were they wrong? Oh, so you're just doing all good. Beautiful. Except for 8? Yeah. Okay. Miss Beamer, are you doing okay back there? Are you sick? Oh, are you sick and tired? Oh, wow. So it's not just a figure of speech. It's both. But when my mom would say she's sick and tired, she was neither. She was just fed up, but not literally. She might have been hungry, actually. And I like your Dunder Mifflin shirt. That's really cool. Yeah. Okay, Jesse. Jesse, this one's really tricky. It says, show that a squared b equals this. The way you do that is you don't simplify this. This would be true, remember, this would be true if you square this and it equals the radicand. That's why it would be true, and that's what it's asking you to do. So you take a squared b and you square it, and if it equals a to the 4th b squared, then you're good. So a squared is a to the 4th, and there you go. That's it. What's up?
Just doing the square root.
No, you're not simplifying the square root. You're showing that this is the answer by checking it, by squaring it. Remember, if you square this and you get the radicand, then it's right. Well, tell you the question. Okay, why is finding perfect squares appropriate when simplifying square roots? Dang. Pierre, why is finding square roots appropriate when simplifying square roots? Why is that better than, say, like prime factorization? You don't have to do that much work, that's true. And why do you have to do less work when you find perfect squares when you're simplifying square roots? Why is it less work? Because what? Are you just guessing stuff now? Okay. All right. You know why I thought he was guessing stuff? Because he started mumbling. Pierre, who do you think knows why finding perfect squares would be less work when you're simplifying square roots compared to doing prime factorization? Parth? Okay. Hi, Parth.
Hold up.
Hold up.
Give me 2 hours.
Really? It shouldn't take that long. I think you know. I think as soon as somebody says why, you're going to be like, oh, I did know that. Abraham, you know why? The smallest thing? Man, you started throwing a lot of pronouns in there once you got confused. That was good. That's good. That's right.
Sense in my mind.
I understand. Probably a lot of things make sense in our minds until we say them, and then it's like, oh, that really was a bad idea. Azalea, do you know? No? Does Allison know?
Is it when when you're ready to solve it, it's easier to solve it when you substitute for the variable?
I don't know what you mean. There's a lot of it's in that whole statement. I got confused. Huh. Does Juliana know?
No.
She's like, nope. Natalie knows?
Is it because you find the biggest factor?
But that's true. I taught you to find the biggest perfect square. But why? Why is that easier than prime factorization? Does Rag know?
So you could reduce it to its fullest.
Reducing is division by the greatest common. Man.
I got a guess.
Okay, let's hear it.
It's
It's a lot of uhs. Why don't you collect your thoughts and come back when you're ready? You know?
It just makes it easier, like,
Yeah, but why does it make it easier?
because
There's a really solid.
because you find the biggest square, I mean perfect square, so that you find your answer quick. I don't know.
Jesse, you know why?
Is it because you find a perfect square? I don't want to word this wrong, but so you find a perfect square, and it's easy to solve that, and you're only gonna have to do one of the factors instead of both of the factors. So like,
What does square roots ask?
What number times itself is
What number squared?
equals the area?
They're asking for squared numbers. That's why you're looking for squared numbers. I know you knew that.
That makes sense.
Yeah, you're welcome.
$10.
That is $10.
Well, I'm poor right now, so
You're poor, that's why I need $10, because I'm poor.
no, but $10.
Can I, hey, you know what? Maybe you can collect 20 from, I don't know, Diego and give me half, and from Kevin, and then you keep half, I get half. Yeah.
Kevin, will you be a loan shark and I have $100?
All right, boys and girls. Wait a minute. Listen. What is that, Parth? What is that, Parth? What is it?
Hey, stop it. Put that away.
Okay, Parth, Brandon. I think you guys knew this, and let's see, when we did square roots 2 days ago, if I asked you this question at the end of the day, you would have spit it out immediately. But then you got so focused on process that you forgot that the process comes from the idea, and this is the idea. Square roots ask for perfect squares. That's the most important thing. That's the thing you always have to go back to. Amen. Okay.